Hi guys, this is Vineet, and in today's video we will talk about the concepts of database files in SQL Server. So let's quickly go to notes. Before we proceed ahead, I would request you guys to please quickly go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that button, you will see a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. So once you're subscribed, and in case you need the copy of these PDF notes, I can send these to you via email. So in order to get the PDF copy of these notes, please first subscribe to my channel. After subscribing to my channel, you have to send me the screenshot of subscription proof. Example is given below, like this, showing subscribed along with my channel name and the name of the video. So once I get your email, please send your email on vrmavane@gmail.com. Once I get your email, I will send you the PDF copy of these notes. Otherwise, what I would suggest is to note down this, jot down these notes while we are discussing the concepts. So today we are discussing about the concepts of database files. So let me select a suitable pen. Give me a second, guys. Okay, so let's talk about database files in SQL Server. So SQL Server Database has two OS system files at the minimum. So at minimum, the SQL Server holds two type of operating system files, which is a data file and a log file. So a data file and a log file. So at minimum, one data file is required for a SQL Server database and a log file is required. And what do these files contain? So a data file, particularly data file we are talking about here, contains data and objects like your tables and indexes, stored procedures, and the views, etc. And what about log files? Log files contain the information that is required to recover the transactions in the database. So basically what log file contains is, it contains the committed and the uncommitted transactions. And those uncommitted transactions can be all those transactions can be used to recover the data in a database. And data files can be grouped together in file groups. So file groups is basically a group of data files or for allocation and administration purpose. So basically, why do we use file groups? We use them for allocation and the administration purpose. And what are the contents of the file group? A file group contains multiple data files. Now let's talk about various type of database files available in our system. So there are following types of files available. Let's see what are those. So we have a primary data file, which has an MDF extension. Basically this extension, this is a primary data file, and what it contains the startup information for the database. So primary database holds the startup information for the database and points to the other files in the database as well. So these two information are contained by the primary data files, the startup information for the database and the location of the other files in the database. And every database has one primary data file, and the recommended file name extension for primary data files is mdf.mdf. This should be the extension of primary data files. And let's talk about the secondary data files. These have a .ndf extension in contrast to MDF for primary files. Secondary files have NDF extension. and these are basically optional user-defined data files, can be created by the user, and data can be spread across multiple disks by putting each secondary file on a different disk drive. So data can be spanned on multiple disks by using multiple files on the separate disk drive, and using file groups to group them, and later on table can be created on the file groups. We'll talk about that. The recommended file extension for the secondary data files is NDF. Other extension can be used, but the recommended extension is .ndf for secondary data file. Third type of data files are the transaction log files. What these holds? These holds transactions, the committed on the uncommitted ones. There are other videos about the transactions. You can watch them. I have some other videos, so you can check out my channel playlist. There are various videos I had made on the transactions, so watch them out. So let's talk about what these transaction log holds. The log holds information used to recover the database. Basically, it contains the committed and uncommitted transaction. So those transactions can be used to recover the database, and there must be at least one log file. So at least one log file is a requirement for each database, and we can have multiple log files as well for a database. And the recommended extension, the file name extension for the transaction log should be .ldf. Alright, let's move ahead. And by default, the data and transaction log files are put on the same drive. So this is the default mechanism of SQL Server. It puts the data file, which are the MDF or NDF files, and the log files on the same drive. And the part to handle single disk system. So why SQL Server places both the data files and log files on the same drive? This basically allows SQL Server to cater the single disk systems where we only have a single drive. So by default, it puts the data and log files on a same drive. Let me show you an example. So for this sample DB, if you go to properties, if you go inside the file section, it shows you the location of these database files: sampledb dat.mdf, sampledb log.mdf. So we can browse these locations. Let me go there. So you see, by default, so let's look out for the file for sampledb. So here we have these two files for samples db. So first one is the log file, the second one is the data file. So by default, SQL Server places both the files on the same drive and the drive path or the folder path. And this is the default behavior, and we need to manually place the file to some other drive to gain some performance benefits. Now let's go back, and if you go to notes, so far we have discussed the default property of putting the files on a single drive or single same drive path. This is basically to cater the single disk systems by the SQL Server, and this choice may not be the optimal for production environments. So this default option is not optimal for production environments, to put the data files and log files on the same location. So what is the recommendation? Recommendation is to put the data files and log files on a separate disks. So this is the general recommendation to gain performance benefits. Now let's go ahead and let's talk about the logical and physical file names. So let me show you inside SQL where we have logical and physical file name. So if we go to the properties of one of your databases and you go to the file section, so here we have a first row which indicates the logical name of the file, and in the last column there is a file name which is basically the physical file name or the OS file name. So let's see the use of both the logical file name and the physical file name of SQL Server. Let's read through notes. So let's discuss about the logical and physical file names. And SQL Server files have two file name types. So one is a logical file name and another one is a OS file name. I've just shown you. So logical file name, what is this? This name is used to refer to the physical file. So this name is used to refer to these files basically. So while writing some queries, we don't directly use the OS file name, but instead we use the logic file name, which is basically a pointer to the physical file name. So the logical name is used to refer to the physical file in all the transact SQL statements that we use. The logical file name must comply. Spelling are not correct, I will correct them later. So the logical file name must comply with the rules for SQL Server identifier. So whatever logical name we are giving to a file, it should satisfy the rules for SQL Server identifiers and must have a unique logical name in the database. There cannot be duplicacy in the logical file names within the database. So those should be unique for each file. Now let's talk about the OS file name. What are they? This is the name of the physical file including the directory path. Give me a second, guys. Okay guys, we have talked about the OS file names, and these must follow the rules for the operating system file names. Basically should satisfy the operating system file name criterion. And let's go ahead, and SQL Server data files and the log files. Okay, so SQL Server data and log files can be put on either a FAT file system or an NTFS file system. These are basically two types of file systems that we can place the SQL Server files on, the data and log files. However, the recommendation is to use the NTFS file system because of its security features. NTFS file system has security features like we can provide permissions on folders, etc. So that's one of the greatest aspects of NTFS. So recommendation is to place the data and log files on the NTFS file system instead of a FAT file system. Our disk drive can be converted from FAT to NTFS file system anytime inside Windows operating system, but this is outside of the scope of this video. So yeah, you may check other videos online or information about this FAT and NTFS file system online. You can read more about that outside in the Google. Now let's talk about the read-write data file groups. So basically here we are talking about the NTFS file system. So if our NTFS file system or drive is compressed, we are using compressed file system on a particular drive. In those drives, we cannot use the read-write data file groups and log files. Those are not supported on NTFS partitions which are compressed. Only read-only databases and read-only file groups are allowed to be put on an NTFS compressed file system. So what we would suggest, instead of using the compression on the drive itself, for space saving we can use the data compression of SQL Server instead of file system compression. So this is one of the good points to consider. Let's move ahead, talk about the data file pages. A page is basically in SQL Server is a unit of storage. A page is 8 KB in size. Data is stored in pages inside SQL Server. Each file consists of lots of pages. So we are talking about the data file having multiple pages. So pages in a SQL Server data file are numbered sequentially. So here we have a diagram. If you see, this is a primary data file, and this file has a file ID which is given by SQL Server. This file has a file ID 1, but ideally this is a different number. So for the example purpose we are taking file ID as 1. So this file contains, the primary data file contains various pages, and these are multiple pages, and each pages has a file number from 0, 1, 2 till whatever number of pages we may have inside that file. And along with that, the file ID is mentioned along with the page number to indicate which file ID this page is allocated to. There is another secondary data file which has a file ID of 2. So pages are spread across that file and sequencing from 0 to 127, and this is a file ID of 2. Alright, so let's discuss about it. So pages in a SQL Server data file are numbered sequentially. We have just shown you from 0 to 511 and 0 to 127. Starting with a 0. So this is 0. For the first page in a file, this is the first page in a file. 0 page is the first page in a file, and each file in a database has a unique file ID. We have just shown you. This is a file ID 1, which is a unique ID given to each file within our database, and the file ID in number. To uniquely identify a page in our database, so how do we uniquely identify a page in our database? We use the file ID and the page number combination. Both the file ID and the page number combination is required in order to uniquely identify the page. For example, we can uniquely identify this page with the file ID 1 and the page ID 2. Let's move ahead. Now, a file header page is the first page, and what this file header page contains, it contains information about the attributes of a file. A file can have various attributes or settings. This header page, the first page of a file, contains the information about the attributes of a file, and several other pages starting from page 1 at the start of the file also contains system information like the allocation maps. One of the system pages stored in both the primary data file and the first log file is a database boot page. So this is also one of the pages, some of the initial pages of a file. One of the pages is called database boot page, and this boot page exists both inside the data file and the first log file. And the boot page basically contains information about the attributes of the database. This is the same as the header page or the boot page. Now let's talk about the file sizing and the auto growth options. So if you go inside SQL Server, you go to properties, you go to file section, we see what all files are allocated to this database along with the initial sizes and the auto growth options. So for example, this primary data file has an initial size of 7. It is allowed to increase by 5 MB once this 7 MB is filled. It is allowed to increase by 5 MB, and there is a limit on the consumption, so it can expand up to 50 MB. That is the maximum file size that can be attained. And auto growth will increase its file size in megabytes with 5 MB, and it can increase up to 50 MB. The maximum size of the file can be 50 MB. So these are the auto growth settings. Let's talk about them in notes. And a file can be specified with the growth increment option. So we have just seen the growth increment option was 5 MB for that file, and that basically this growth option let it grow automatically from their originally specified size, which is the initial size of the file, which was 7 MB in our case. I've just shown you. So these auto growth options allow files to expand till its maximum size from the originally specified size or the initial file size. Every time the file is filled, it increases its size by the growth increment. If there are multiple files in the file group, so here we were talking about the one file. When a file is filled, it gets auto incremented by the specified amount we mentioned in the properties. And suppose if we are using file groups that contains multiple files, a file group generally contains multiple files, so what happens with them? They won't auto grow until all the files are filled within that file group. So this is one of the things to be considered or keep in mind regarding the file groups. So if a file group has 4 files inside it, until all those 4 files get filled, the auto grow operation will not happen. Let's move ahead. We can also specify the maximum file size. We have just shown you the 50 MB was specified as the maximum size for the primary data file, and this can be specified for each file. And if this is not specified, if the maximum size is not specified, a file will grow until it has used all the available space on the disk drive. So if the maximum size is not specified, a file can grow up till all the available space on the disk drive is consumed if a auto growth option is mentioned on the file. Now let's talk about the database snapshot files. What are those? And basically these files are used by database snapshots. So database snapshots, we take database snapshots and it stores this information in our files. And these files are basically used by database snapshot to store is copy and write and data. Depends upon whether the snapshot is created by the user or used internally. So some of the snapshots are created by users, some of the snapshots are created by system. So both of them uses one of them uses the files, other uses the snapshot streams or file streams. Let's talk about each of them. So for example, a user created database snapshot, what does it do? It stores its data is in one or more sparse files. So these snapshot files are basically sparse files, and whatever a user takes a snapshot, whenever user takes a snapshot, it stores its data in one or more sparse files. And sparse file technology is a feature of NTFS file system. Now let's talk about the automated generated snapshots. So database snapshot are also used internally by certain DBCC commands, and these commands are like dbcc check db, dbcc check table, dbcc check allocation, and dbcc check file group. And whenever we use these commands, it uses the database snapshots. And an internal database snapshot, these are called internal database snapshots, and it uses the sparse alternate data stream instead of sparse files. It uses the sparse alternate data streams of the original database files. So original database files has some alternate sparse data streams which are used by the DBCC commands. And like sparse files, alternate data streams are feature of NTFS file system as well. And basically the sparse data stream allows for multiple data allocations to be associated with a single file. So guys, we are done with this topic. So what all we have discussed today? We have discussed today about the concepts of database files, how many type of data files are available, primary, secondary, and transaction log files we have talked about. And we have also talked about the logical and physical name of the files, basically the logical file name and the OS file name. And we have also talked about the data file pages, which is a unit of storage inside SQL Server. A page is 8 KB in size. We have also talked about the file size and auto growth options. And apart from that, we have also talked little bit about the database snapshot files. So guys, we are done with this video today. If you really like this video, please like, comment, and subscribe. In order to subscribe, please click on the subscribe button below this video. And in case you need the copy of these notes, please subscribe to my channel. Send me the proof of subscription on the email address vrmavane@gmail.com. Sample is given below. Once I get your screenshot, I will send you the PDF copy of the notes we are discussing about. So guys, I thank you so much for your time, and you have a wonderful day ahead. Have a nice day. Bye bye.